In the vast emptiness beyond our solar system, where the sun's influence fades into a cosmic whisper, a lone spacecraft has just rewritten the rules of the universe. Voyager 2, a relic from 1977, launched when disco ruled and computers filled entire rooms, has defied every expectation. It's now over 12 billion miles from Earth, drifting through the uncharted waters of interstellar space. And it's sent back a discovery so shocking, it's forcing scientists to question everything they thought they knew about the cosmos. This isn't just another data point in humanity's quest to understand the stars. This is a revelation that's shaking the foundations of astrophysics, hinting at a universe far wilder and more alive than we ever imagined. So, buckle up, because what Voyager 2 found out there is nothing short of mind-bending, and we're diving straight into it. If you're as blown away as we are, smash that like button, hit subscribe, and let's unravel this cosmic mystery together. Picture this: a spacecraft no bigger than a car, built with tech that's now practically ancient, sailing through a realm where temperatures hover near absolute zero. Voyager 2 wasn't supposed to last this long. It was designed for a 5-year joyride to snap pictures of Jupiter and Saturn, maybe sneak a peek at Uranus and Neptune if it got lucky. But here it is, 48 years later, still phoning home from a place no human-made object has ever been: the space between the stars. It's crossed the heliopause, that invisible boundary where the sun's solar wind gives up its fight against the galaxy's vastness. Scientists call this region the interstellar medium, a place they once thought was a cold, empty void, a kind of cosmic no man's. But Voyager 2, it's telling a different story, one that's turning heads at NASA and beyond. The data streaming back from this aging probe has revealed something impossible. Interstellar space isn't the quiet, featureless expanse we expected. It's alive, chaotic, pulsing with energy and structures that defy our best models. Imagine scientists hunched over their computers expecting predictable readouts, only to find their screens lighting up with anomalies that make no sense. Magnetic fields twisting and flipping in ways they shouldn't. Plasma, that charged soup of particles, vibrating with a ferocity no one saw coming. Cosmic rays, those high-energy particles zipping through the galaxies, spiking and plummeting in patterns that scream something's out there. This isn't just a tweak to the textbooks. This is a cosmic curveball, forcing researchers to rethink the very nature of the space beyond our solar system. Let's start with the magnetic fields, because this is where things get weird. Beyond the heliopause, the sun's grip weakens, and the galaxy's magnetic fields take over. Scientists figured these fields would be orderly, aligning smoothly with the galaxy's flow. But Voyager 2's instruments painted a different picture. The magnetic fields out there are restless, twisting and reversing in ways that don't match any theory. These aren't random blips, either they're sustained, patterned, like a cosmic dance we don't yet understand. One NASA researcher described it as finding a river where you expected a desert. These reversals could mean the interstellar medium is shaped by forces we've never accounted for, maybe relics of ancient supernova or gravitational ripples from distant stars. Then there's the plasma, the electrified gas that makes up much of the universe. Inside the heliosphere, plasma flows with the solar wind, predictable and turbulent but familiar. Out in interstellar space, scientists thought it would spread thin, calm down, become a gentle background hum. Wrong. Voyager 2 found dense pockets of plasma vibrating with intense, almost musical harmonics. These aren't soft ripples, they're powerful waves, carrying energy across vast distances. Some researchers are whispering about unseen structures, like invisible barriers or shells formed by long-gone cosmic events. Could these be echoes of ancient explosions? Or something entirely new? Whatever they are, they're shaking up our understanding of how energy moves through the galaxy, and don't get me started on the cosmic rays. These high-energy particles, born in the hearts of exploding stars, zip through space at nearly the speed of light. They're the universe's messengers, carrying clues about its violent past. Scientists expected their intensity to smooth out in interstellar space, a steady stream from all directions. Instead, Voyager 2 recorded wild swings, sharp spikes, followed by sudden drops. It's as if something out there is blocking or funneling these particles, creating invisible walls or channels. Some speculate about magnetic islands, pockets of trapped magnetic energy, or turbulent eddies in the interstellar plasma. Whatever's causing it, these anomalies are rewriting the rules of how cosmic rays travel, which could change everything from space weather forecasts to the safety of future missions. This discovery isn't just a collection of weird data points. It's a glimpse into a universe that's far more dynamic than we ever imagined. For decades, we pictured interstellar space as a near-perfect vacuum, a cold, dead void where nothing much happens. Voyager 2 says otherwise. It's showing us a cosmos that's more like an ocean, with currents, waves, and turbulence shaping its depths. This isn't just about rewriting a few equations. It's about rethinking our place in the galaxy. If the space between stars is this active, it could affect how we model the protective bubble around our solar system, how we predict cosmic radiation, even how we search for life out there. Speaking of life, let's go there for a second. The idea of interstellar space as a sterile wasteland just took a hit. These findings: energetic plasma, Twisting magnetic fields? Structured cosmic razagest, a medium that's anything but empty. Panspermia, the theory that life's building blocks hitch rides on cosmic dust or meteorites, suddenly feels a bit less far-fetched. If interstellar space is buzzing with energy and organized structures, could it be a highway for microbial travelers? Maybe the seeds of life aren't just confined to planets, they're drifting through the galaxy. Carried by these turbulent currents, it's a long shot, but Voyager 2's data is making scientists wonder. The implications don't stop there. Cosmic rays, those high-energy particles, are a big deal for future space exploration. They're a radiation hazard for astronauts and a challenge for spacecraft electronics. If interstellar space is as chaotic as Voyager 2 suggests, our models for predicting cosmic ray exposure are probably wrong. That's a problem for missions beyond Mars, where radiation shielding becomes a make-or-break issue. Future probes, or even human explorers, will need designs that account for this newly discovered turbulence. Think adaptive magnetic shields, or advanced plasma sensors tech we haven't even built yet, inspired by a spacecraft older than most of us. Then there's the bigger picture, how stars and galaxies evolve. Magnetic fields are the unsung heroes of the cosmos, shaping everything from star formation to the structure of galaxies. Voyager 2's data hints that these fields behave differently in interstellar space than we thought. If these findings hold up, they could unlock new insights into how stars influence their surroundings, how galaxies hold together, even how exoplanets form in distant systems. Some scientists are even speculating about interstellar filaments, thread-like structures of plasma and magnetic energy that might connect to the cosmic web, the massive network of matter that spans the universe. If Voyager 2 has grazed one of these, it's the first direct evidence of such structures near our solar system. What makes this also jaw-dropping is that nobody saw it coming. Decades of simulations, models, and theories didn't predict this. The interstellar medium was supposed to be simple, a baseline for studying the galaxy. Instead, Voyager 2 found a cosmic storm, a place where the rules of physics play by their own script. NASA's teams are scrambling to make sense of it, poring over terabytes of data from a spacecraft that's barely holding together. Its power supply is fading, its instruments are decades old, yet it's still sending back signals that challenge our best minds. That's not just science, it's a testament to human ingenuity. Let's talk about Voyager 2 itself for a moment. Launched in an era when calculators were cutting edge, this probe is a marvel of engineering. Its computers have less power than your smartphone's calculator app, yet they're still crunching data in the harshest environment imaginable. It communicates with Earth using a signal so faint it takes hours to reach us, relayed through massive dishes that strain to hear its whispers. Operating at near absolute zero, with a plutonium-powered heart that's slowly decaying, Voyager 2 is a survivor. It's outlasted its creator's wildest dreams, becoming humanity's explorer, and now, it's rewriting the story of the cosmos. This discovery also raises big questions about what's next. If interstellar space is this complex, future missions will need to be tougher, smarter, more adaptable. Engineers are already thinking about propulsion systems that can handle these dynamic conditions, or sensors that can map plasma waves in real time. The data from Voyager 2 could inspire a new generation of spacecraft, ones designed not just to visit planets, but to navigate the turbulent seas of the galaxy. And who knows, maybe this is the push we need to finally crack the secrets of interstellar travel, bringing science fiction a step closer to reality. But beyond the tech, there's something deeply human about this moment. Voyager 2 is a reminder of what we're capable of when we dare to explore. It's a piece of us, a tiny machine carrying our curiosity into the unknown. When it launched, the world was a different place. Cold War tensions, no internet, no smartphones, yet that same world built something that's still teaching us, still surprising us, nearly half a century later. It's humbling to think that a machine from the Carter era is showing us how little we know about the universe. It's a call to keep pushing, to keep questioning, to keep reaching for the stars. So, what does this all mean? It means the universe is stranger, more vibrant, more alive than we ever thought. Every magnetic twist, every plasma pulse, every cosmic ray spike is a clue to a bigger story, one we're only beginning to understand. Voyager 2 has given us a glimpse of a cosmos that's not a silent void, but a dynamic frontier, full of mysteries, waiting to be solved. Scientists are already working on new models, new simulations, new ways to test these findings. But the truth is, we're at the edge of the unknown, and Voyager 2 is our guide, still whispering secrets from 12 billion miles away.